Hi there, this video is about the hedonic pricing method. This is basically a pricing method in which we try to value a certain resource and we try to overcome the problems like omitted variable problem and the self-selection problem. These are the two problems that are confronted and they are coped with in this method. Now let us see that how this method is adopted. It is also known as the hedonic regression method because we resort to the regression process in this method. We can overcome this problem, and that can be done by incorporating some additional variables that are explanatory variables. And the other problem that is overcome is the self-selection bias, and that can be done by incorporating a variety of the people with various socioeconomic backgrounds and hence the tastes, so that only one kind of people who prefer a certain attribute of a certain good are not selected. Now we come to the various terminologies and how we can quantify the various attributes, and the value of the change in the attribute is going to affect the price of an asset. For instance, if we talk about houses or salaries, these are the two valuation processes in which we value a certain real estate, and if it is having a good view when one lives in it, it is going to have a greater price, and if the neighborhood is good, the house will have a greater price, and if it has proximity with good facilities, then again the price will be higher. When it comes to salaries, the salaries, they are dependent upon the efficiency of the individual, his education and his experience, among other traits. So these are various hedons or features that increase or change the value of an asset. And if we focus on the housing example, the scenic views are one of the attributes that can affect the price of an asset. The scenic views, though it's an intangible thing, we can still try to value it, and we adopt a certain scale that starts from 1 and end at 10. This is one of the ways. There can be other ways, but this is a very simple method of valuing the scenic views, and it can affect the value of the area by 1 unit. We can check that. And you remember that such a calculation is adopted in regression, where we quantify the effect of one variable on the other. There are other factors as well. For example, size of the lot, that is the overall housing scheme. That can be a large housing scheme or a small housing scheme. That is one of the other factors that can be considered. There are other factors as well, neighborhood or approach to the central business district. All these factors can affect the value of the house. Now the size of the lot, the overall housing scheme, if it is large, it can have a good view, but that's definitely not a carving in the stone. It can happen, but sometimes it might not. But if we have a large society, the view can be better because it might be managed in a good way, since it's a large society and the regulation and the administration is good. So this correlation can be there. So such problems can arise when it comes to the valuation. And another situation is that the quality of the scenic views will be better for those who are already living in places where the scenic view is better from that house. So it means that people will value the scenic views if they are in a better house where the scenic view is already there. So if we collect the data from them, it means that we are choosing the same people who already have the higher preferences for scenic views. So that will cause self-selection bias. And omitted variable bias can also be overcome by including variables like these and others that we will see in a while. So the first thing that we do is that we overcome the omitted variable bias by including all the possible attributes that can affect the value of that asset. Marginal effect of an attribute is found here, that how 1 unit change in the attribute can cause the change in the various on the overall price of the house. Self-selection bias, what we do is we estimate the WTP for the attribute, and in that process we control for the tastes, and the tastes, they are proxied by socioeconomic factors, because the socioeconomic factors, they determine the taste of the people. Now using this we can find out the various variables like consumer surplus and how it changes when the attribute improves or deteriorates. So let's talk about the hedonic price specifically. We are focusing on one of the factors, that is the attribute of scenic view. The first step is to find out the hedonic regression. By hedonic regression we mean all those features are included in the regression that can affect the value of the house. These features or attributes, they include the quality of the scenic view, represented with this acronym, and the distance from the central business district, CBD, and size of the lot, size, and the characteristics of the neighborhood. These are four of the factors that we have chosen, the hedons or the attributes that can affect the overall price of the house. This is known as the hedonic price function or implicit price function, because it includes the hedons of the features, and the implicit factors, they are included in this. We can find out the per unit change in the attribute and then see how this per unit change affects the price, as we usually do in our regression analysis. And when we do, it will become the hedonic price or the implicit price or the rent differential, and that will be defined as the additional cost of purchasing a house that is marginally better in terms of a particular attribute. So see, the regression thing is appearing here, marginally better, and the cost. Here the additional cost of purchasing means the price that the buyer has to pay. So we represent the hedonic price with respect to scenic views with the RV, because it is the rent differential, and it is the additional cost of buying a house with slightly better or marginally better scenic view. So when we say that it is marginally better or slightly better, it means that we can also call it marginal hedonic prices or marginal implicit prices. We are avoiding the word marginal here, and we are simply calling it hedonic prices for the sake of brevity. Now we observe that the usual assumption regarding the functional form is multiplicative functional form. The function that we just saw here, it is represented in multiplicative form. And when we do this, we see that the first derivative with respect to the attributes is positive, and the second derivative with respect to the attributes is negative, which means that as the attribute increases, the price will increase, but at a decreasing rate. You will see this in the diagram as well. So now we express the function in the equation form, which is in multiplicative functional form. This is the error term. These are the various hedons or the features that we refer to, and these are their powers that represent the elasticities of the various factors, that how they affect the price. These are the four elasticities. Definitely they show the proportional change in one factor and how it affects the overall price. The beta 1, if it is negative, then the price it is actually negative, because when the price is declining, it shows that the distance from the central business district is high. Definitely if it is close, the price will be higher. The other factors, that are positively related, because as the size of the lot increases, as the view improves, as the characteristics of the neighborhood become more favorable, the house price will increase. Now these hedonic prices of the various attributes, they are actually the slope of the equation with respect to the attribute. As you can see, we have plotted this graph that we will see here, as we have focused on the rent differential or the hedonic price with respect to view, so we are writing that, and view is becoming one of the independent variables, and y and z, they are there. Y is showing the income and z is showing the various socioeconomic factors. We can see that here. You can see that it is tastes at the socioeconomic factors, and this is the income. Here we have explained this. Now we come to this diagram and we see that it's a downward sloping curve when it comes to this graph. But primarily, if we focus on this is as we understood before, that it is in this form, and if view increases, the price will increase, but at a decreasing rate. So you can see if the view is improving from left to right, the price will increase, but at a decreasing rate, because the curve is showing an increasing trend at a decreasing rate. There are 3 points that we choose because of various levels of views: V1 and V2 and V3, RV1, RV2, RV3. These are the various tangents that we have plotted, because the slopes are calculated on these 3 points. The slope here is higher, then it's lower, and this is flatter. So the slope means that the effect of the views, it is high here because high rate of change, or the slope lesser and the least. So the hedonic price function is this curve, and the tangents are basically the hedonic prices with respect to the views. We have to differentiate between hedonic price function, which is this curve, and the marginal hedonic price with respect to the attributes, which is actually the slope at various points. Now these slopes are borrowed and they are plotted on the other panel of the graph. The level of the scenic view is the same, and now we are having the hedonic price of the scenic views. So this is the representation of those slopes. This is RV. If we consider this is the curve that shows the slope of the hedonic price function with respect to the scenic views. As we saw that it was having a declining trend, the rate of change was decreasing from left to right. Here you can see this rate of change is decreasing from left to right. Talking about these W's, this is W1, W2, W3. This is basically showing the various households that we have taken with different preferences. They are having different preferences, and they are these preferences are represented with their socioeconomic background, race, age, and family size. We have chosen 3 of the households with different preferences, and hence their WTPs are different. So their WTP functions are plotted here. This is W1, W2, W3, and when we estimate and plot these W curves, we will see that they appear here. W1, W2, W3. They intersect the marginal hedonic price at this point, and at this point, and that point. So we have a variety of households with different WTPs and different preferences. So the chances of having the self-selection bias will be mitigated, because we are not choosing the same people who are having similar sort of preferences, and probably they are biased, or they are preferring the scenic views. So this helps us to get 3 points of intersection and to show the equilibrium, because this line is showing the hedonic price, or the rate of change with respect to scenic views, and this is the inverse demand function. In other words, the price is here, the quantity is here. So this inverse demand function and its intersection with the various willingness to pay functions is going to give us the household equilibrium willingness to pay. So now we have this household equilibrium willingness to pay. It's not just willingness to pay, it is also showing the equilibrium. It is a locus because it's a straight line. It's a line joining various points. So this also helps us to overcome the self-selection bias. There are other few things that have been explained in the diagram, but we can also see the explanation here. This is the description of the first panel of the diagram. This is the second panel of the diagram. Now this is the equilibrium condition, that if there is a well-functioning market free from externalities, then the utility maximizing households will purchase the houses, definitely in a situation where the value that they pay is equal to the cost. Value that they assign is equal to the cost that they pay. So WTP is equal to the price that they pay, the cost that they have to incur with respect to views, and this is the WTP, which is the marginal increase in the views. So this will give us the equilibrium that we are trying to represent in the bottom panel of the diagram, and that is why it was known as the equilibrium willingness to pay of the households. We also saw that there was a negative slope in the inverse diagram, inverse demand function. And so the description is here. We have already talked about this function, which is the marginal hedonic price with respect to views. This is the explanation that we have already talked about. Now we should focus on the problems with this method. The first problem that we face in this process is that the full implications of the various hedons or features or attributes, they are not usually understood, and they can cause externalities, or there can be public goods involved in it. So the negative externality of pollution, that is difficult to assess for many of the people, because if people live in such an area in houses where there is high level of pollution, then they will be exposed to the pollution, then there will be health issues, and then they realize the actual consequences of the pollution. So the implications are not commonly known by the general masses, and they can misguide us with their poor responses when it comes to the WTP regarding the pollution or any other attribute. Secondly, the correct measures should be used, and not those measures that are readily available, because they can become incorrect proxies. For example, the quality of the construction of a house, if this is to be assessed as a feature or the attribute, it is quite difficult, if not totally difficult, because without the inspection it is quite difficult to do an in-depth inspection of the house. So what people do is they take the year of construction as the proxy of the quality of the construction. So that can be used, but this is not one of the best proxies, because thorough inspection can be a better idea. So in the econometrics, it is known as the error in the variable problem. This should be overcome, but there are barriers, because thorough inspection might not be that much easy or permitted by the sellers. Thirdly, the Hedonic prices model is if it is linear, then the slope of the marginal price will be 0. Let us see with the help of this diagram. We saw that it had a positive slope and it had a decreasing rate. So the slope was having a certain trend, that is, initially it was high, then it reduced and further reduced. So when we plotted this function, it was negatively plotted. But if I assume that the slope is constant, for example, if it is a straight line, the slope will be the same, which means that there will be a straight line here in the form of a hedonic price, scenic views, which means that a straight line at different levels of views, the hedonic price will be the same. So that can cause difficulty in our understanding of the process, because this is not realistic. As the views, the quality changes, it may give us lesser utility, and we might be lesser willing to pay for it. But this shows that we will have the same willingness to pay as we go ahead. So this is something that is not logically acceptable. This is why when it comes to linear hedonic pricing methods, it is not easy to understand and make sense of it. That's why we saw that multiple functional form was used and multiple specification was able to give us better understanding of the situation. Now the fourth problem is that the people might not be well aware, or there can be quite a bit of disparity among the people regarding the optimal package, that what sort of attributes are the best mix of all the attributes. For example, the small, the pollution free house and other features, when we mix them, some people would prefer the features of the neighborhood, some people will prefer the scenic views, some people will prefer the other facilities. So how much of the which of the facility should be mixed up in order to give the overall best package? This is a very contentious thing to decide, because all of the people, they will have their own ways of giving various weights to various features. For example, if there is a family which is looking for small and pollution free house, it is not very much likely, because the pollution free areas are usually large. They are not small lots, because that's where the pollution can be easily spread. Then there can be multicollinearity problem, which is a statistical or econometric problem, and that can arise because features can be interrelated. For example, if the houses were large, they were likely to be free of pollution, and the inexpensive houses, they were small and they were located in polluted areas. So you see, there is correlation between these two attributes, that is the size of the lot and the level of pollution. When we put these two in the regression on the right hand side as the independent variables, there will be problem of multicollinearity. And the final problem is that the market prices might not adjust immediately as there are changes in the attributes. It can involve some lag, some time, but however, we assume here that as the attributes, they change, they immediately get translated into the changes in the overall price of the certain asset in the market. So that's why that's not one of the best assumptions to make. This is a set of limitations of the hedonic pricing method, and this was the explanation of those diagrams, the equilibrium condition, and these were the two diagrams, the two panels of the diagrams. And then this is the model that we developed, a multiplicative functional form, and this was the hedonic pricing function. This is the development of the function. These are the two problems that we face in the hedonic pricing method: omitted variable bias and self-selection bias. And this is the pricing method, which is known as the hedonic pricing method. Thank you.